Stainless steel is everywhere. Kitchen sinks, cutlery, appliances, elevators, handrails, buildings. It looks clean, modern, and durable. And most importantly, it does not rust, at least not in the way ordinary steel does. This often leads to a simple assumption: stainless steel must be immune to rust. But that assumption is not entirely correct. Stainless steel does not rust easily, but not because it ignores the laws of chemistry. It resists rust because of how it reacts with the environment. To understand why, we first need to understand what rust actually is. Rust is a form of corrosion that occurs when iron reacts with oxygen and moisture. This reaction creates iron oxide, which flakes, weakens the metal, and spreads over time. Ordinary steel contains iron, so when it is exposed to air and water, rust forms naturally. Stainless steel also contains iron. So why does it behave differently? The answer lies in what else is mixed into the metal. Stainless steel is not a single material. It is a family of alloys. What makes them stainless is the presence of chromium. Chromium is the key ingredient. When chromium is added to steel at a sufficient level, something interesting happens. Instead of allowing iron to react freely with oxygen, chromium reacts first. This reaction creates a very thin, invisible layer of chromium oxide on the surface of the metal. This layer is crucial. It acts as a protective barrier that prevents oxygen and moisture from reaching the iron underneath. Without access to oxygen, the rust reaction cannot continue. What makes this layer especially effective is that it is self-healing. If the surface of stainless steel is scratched or damaged, the exposed chromium reacts with oxygen again, reforming the protective layer automatically. This happens without any visible change. That is why stainless steel can maintain its appearance even after years of use. The metal is not rust-proof. It is rust-resistant by design. The chromium oxide layer is stable, tightly bonded, and extremely thin. It does not flake off like rust. It stays in place and protects what lies beneath. This mechanism explains why stainless steel works so well in everyday environments. However, it also explains why stainless steel can still corrode under certain conditions. If the chromium content is too low, the protective layer is incomplete. If the environment is too harsh, the layer can be overwhelmed. High salt exposure, extreme acidity, or lack of oxygen can interfere with the protective process. That is why some stainless steel items still show signs of corrosion, especially near the ocean or in industrial settings. Not all stainless steel is the same. Different grades contain different amounts of chromium and other elements like nickel and molybdenum. These additions improve corrosion resistance, strength, and durability. This is why some stainless steel is used for cutlery, while other types are used for medical equipment or marine hardware. The environment determines the alloy. Another important factor is oxygen availability. It may seem counterintuitive, but stainless steel needs oxygen to stay stainless. The protective layer requires oxygen to form and repair itself. In low oxygen environments, stainless steel can actually corrode more easily. This is why stainless steel performs better in open air than in stagnant water or sealed crevices. The design of an object matters as much as the material itself. There is also a difference between surface staining and true rust. Sometimes stainless steel develops discoloration that looks like rust. In many cases, this is caused by contamination from other metals or surface deposits, not corrosion of the stainless steel itself. The underlying metal remains intact. This can be misleading, but it does not mean the material has failed. Understanding this helps explain why stainless steel is so widely used. It offers a balance between durability, appearance, and maintenance. It does not require coatings or paints to protect it. The protection is built in. This makes it ideal for environments where cleanliness and longevity matter. The concept behind stainless steel also reflects a broader principle in material science. Instead of trying to block reactions completely, engineers often design materials that manage reactions intelligently. Stainless steel does not prevent oxidation. It controls it. By allowing a controlled reaction at the surface, it prevents a destructive reaction deeper inside. This approach is more reliable than relying on external coatings that can wear away. Once the coating is gone, the protection is gone. Stainless steel carries its protection within the material itself. That is why scratches do not automatically lead to failure. It is also why stainless steel can last for decades with minimal care. So when people say stainless steel does not rust, what they really mean is that it rusts in a way that protects itself. It forms a barrier instead of breaking down. This distinction matters. It shows how a small change in composition can completely alter behavior. Stainless steel is not magic. It follows the same physical laws as any other metal. It simply uses those laws to its advantage. And that is why stainless steel does not rust the way ordinary steel does.